You look like a guitar guy. Yeah, I think it's the hair. Day 16, Reindeer Maze. It's time again for the Reindeer Olympics. This year, the big event is the Reindeer Maze, where the reindeer compete for the lowest score. Ooh, like golf. You and the historians arrive to search for the chief right as the event is about to start. It wouldn't hurt to watch a little, right? Nah, I don't think so. I don't think it would hurt. The reindeer start on the start tile, marked S, so convenient, facing east, and need to reach the end tile, marked E. They can move forward one tile at a time, increasing their score by 1 point, but never into a wall. They can also rotate clockwise or counterclockwise 9 degrees at a time, increasing their score by 1,000. Okay, so a single movement costs 1 point, and a rotation in 90 degrees in either direction costs 1,000. Without even reading ahead, as this is going to be some Dijkstra and using these weights as like a heuristic or something. But let's read on. To figure out the best place to sit, you start by grabbing a map, your puzzle input, from a nearby kiosk. For example, there are many paths through this maze, but taking any of the best paths would incur a score of only 70-36. This could be achieved by taking a total of 36 steps forward and turning 90 degrees a total of 7 times. Okay, so they show me what the ideal path would look like. Okay, that's the ideal path. Here's a second example. Oh, it's a different maze. Okay. In this example, the best path costs 11,000, etc. Following one such path would look like this. Okay, so it gives me 2 examples and what their best path look like. Note the path shown above includes 1 90-degree turn as the very first move. Okay, cool. So you started facing east, but you had to rotate. There's nothing you could do there. Okay. Analyze the map carefully. What is the lowest score a reindeer could possibly get? Whew. This is going to be interesting. Yeah, let's see how this goes. Make dir. Day 16. Cool. Now we have, I don't know, we'll do like example 1.txt. And we'll grab it from the website. 2.txt. We'll also grab this from the website. Oh, you want a link to my Spotify? Here, I'll show it to you actually. Give me 1 second. So yeah, here's my Spotify up here. Here's what it'll look like when you find it. You'll find my whole discography. Nightfall is definitely my best album. It's my latest one. I already have some ideas, but let's just start programming. And then I'll explain what's going on. Vim part 1, we're going to do what we've done a million times here. But we should be getting really good at it. Now, let's just go copy this, because we've done this logic 8,000 times, right? Let's just copy this from an already existing day. So day 15, I think, also had the 2D maze logic. Yeah. Yep. Yeah, we already had this. So let's go ahead and pull this from day 15. Let's go back. And now we will grab the print grid. There we go. Grab these, and we'll put it in. Okay, so a lot of stuff's happening here, but we have a print grid function. And then we read in our data. Okay, so we're gonna read in the initial grid, and we have 2 points we need to care about. Start point and end point. These are the 2 things we care about. So we read it in, and then we check if the character is an S, then start point equals this, and C is a dot, because it's technically a free space. And then we'll do elif, it's a E, then end point equals this, and then we set it equal to a dot, and then we do that, and then we'll run print grid, and then print grid can go over here and just do this. If key equals start point, we'll do a lowercase s and a lowercase e, so we'll know that we've modified it slightly. So now if we run this with the example 1, it'll look like that. whereas here's what example 1 looks like normally. So as you can see, it looks identical, which is good. That's what we wanted. The only difference is lowercase e and lowercase s, meaning that we've actually processed this data. We're putting it into our own type, and then we're actually able to reconstruct it based on what we have. All right, so what are we doing? We have a map, and we have to find the optimal path through this maze. We always start facing the right. So let's do start direction equals this. Okay. Yeah, we'll just do a character. We want to find the optimal way through this maze where turning is the last thing we want to do and moving forward is the first thing we want to do. So I think we're going to have to approach this similar to like Dijkstra's or something. We're going to have to do like a breadth first type of thing where we look at all possible ways we can go and then we weight them based on how hard it would be to actually move there. So like we're standing in this starting position. Our possible moves are go east, and that costs 1 point. Rotate 90 degrees this way and go nowhere. Rotate 90 degrees counterclockwise and go north, which would cost actually just the rotation. Sorry, there's only 3 moves you can do. Move forward, rotate left, rotate right. Let me simplify this. There's 3 moves you can do. Both rotates are 100 points or 1,000 points, and going straight is 1 point. So I think what we need to do is we need to create like, I forget what this data structure is, but it's like a queue. There's a name for this type of thing. It's a tree structure underneath it. I can't think of what it is. I'm pulling CS logic from 15 years ago. But we need some sort of data structure where we can put all possible moves, but we need to prioritize the cheapest moves because those are the moves that we want to do. So for instance, from our starting position, we want to move to the right. We want to go here first because that's cheap. However, I can see that we're going to hit this wall soon, so we're not going to be able to do that. But we're going to need to unwind that. So we're going to end up with a tree structure of all possible moves, and every like leg of the tree, what's the word I'm looking for? It's going to break the moment we can't move anywhere, or we have to go back on ourselves and visit a node we've already visited with the same direction. That's how we'll know that we visited before. So we have to go this way until we eventually get to the end with the cheapest thing, and we keep prioritizing visiting the cheapest place. So once we get to the end, we should know it's the cheapest because all other possibilities haven't got there yet. Once we get to the end, we should be able to reverse through that tree, go backwards through the tree structure, and we should have our path. This is just, this is like a shortest path algorithm type of thing. I've at least encountered this before, so I'm somewhat decent at recognizing that this is the case. So I don't know exactly how we're going to store this yet, but let's try and think of this. So, so we can do 3 things from every position we're in. So we're going to do while true, done. The 3 things, actually, let's just step once. We'll worry about putting in a while loop later. So the 3 things we can try are, let's call it moves as an array. We can try going right. We need to come up with 3. We need an enum of 3 different things we can do. Let's just give them names. Forward, clockwise, counter, clockwise. These are the 3 moves that we can possibly do. We can move forward, we can move clockwise, or we can move counterclockwise. They each have their own weight to them. But we'll put forward at the beginning because I think that just prioritizes it. We're going to have to, we'll work through some of this logic. So now we have to try each of those moves. For move in moves. Do, done. In order to move forward, we need to know our current direction. Let me think about this. We're gonna have to embed a lot of information into this. So I'm gonna think about this. Give me a moment. I'm gonna lock in. Yeah, we're gonna have to embed some information into each one of these. Like, you could change your cursor character. Yeah, I totally could. When it comes time to print it, I will do that. How'd you choose your channel name? I said it once on a video 2 years ago, and then it stuck. So here I am. That's how people knew me. So I believe in organic branding. That's how people knew me. So that's how I'm going to brand myself. I'm just going to write some code, and we're going to have to change this. Cur direction equals that. So if you want to move forward, try move forward. If we want to move forward, we need to take our cur location equals start direction start location. Okay, we have a cur location and we have a current direction. In order to try to move forward, we need to say we're going to break this because it's an x comma y value. We're going to break it on commas. We have the x and the y of the current location. In order to move forward, we need to know what our current direction is. So we'll do a case around our cur direction. And there's 4 possible directions, so we're either going, up. If we're going up, then we need to do y minus minus. If we're going down, then we have to do y plus plus. If we're going left, then we do x minus minus. If we're going right, then we do x plus plus. So what we have done here. Also, are all the maps guaranteed to be surrounded by... Oh yeah, all the maps are surrounded by hash marks, pound signs. So we don't have to worry about going out of bounds, which is super nice. Let's see. So what we have here is we got our current direction and we have our current location. And if we're moving, here's what the next thing to try is. So now we have our x and our y where we have to try what that would be. I'll just put a to do here. Then we will do, what should we do? Try, move clockwise. I'm going to overwrite some variables, but we're just getting the logic in there. Cur direction in. We'll grab these because we already have the current direction. And now we just have to set next direction equals, if we're facing up, then we want to face to the right. If we're facing down, then we want to face to the left. If we're facing left, we want to face up. And if we're facing right, then we want to face down. That is clockwise rotation. And then we have to do try, move, counterclockwise. So there's 3 things we have to try for each direction. Okay, this is fine. This is left, this is right, this is down, and this is up. Easy. Map might work here. I have no idea. I'm not sure what you mean. Cool. Put a nice little to-do here because we actually have to write some logic. And we'll put a nice little to-do down here because we have to write some logic. So here's the 3 possible things we can do in the order that we can do them in. In order to try and progress, we have to do 3 possible steps based on where we currently are, and each one has a weight associated with them. So now that we know where we are and where we're going, we have to push this as an instruction onto a queue. Let's make a queue. Let's add this to the queue, plus equal, x, comma, y, comma, cur direction. Then when we're down here, once we're down here, Then we will queue up cur location next direction. And then we will queue up cur location next direction. So what we've done, let's just print this out now. I'm going to pull in code that I've written before, which is called vardump, and it is a bash library, basically a single function that just lets me dump a variable, similar to util inspect in Node, p in Ruby, I think, or pp. I think the functions might be called pp. I'm not laughing at that. I'm not juvenile, I swear. cp day 14 vardump into day 16, cd into day 16, vim part 1. Let's pull in vardump here. And then let's vardump the queue. So this will print out what we've put in the queue. So part 1, read in from example 1. Cool. So what we've put in the queue is, wow, we're missing some numbers and letters here. Cool. What did we do wrong? What's the first one missing? We have x comma y comma direction. We have the y is not set there. Cur location is start location. Start location is never set. That makes sense because we called it start point and end point. Yeah. Let's change start point to start location. And let's change end point to end location. And let's just try to be consistent. There we go. Okay. So from this starting point, there are 3 possible places we can go. We can move to x2, y13 with a direction of right. We can move to the exactly where we are with a direction of down. Or we can move exactly where we are with a direction of up. So we know that because this one's at the beginning, that's the one we're going to prioritize. We want to do this one. This is what we want to do first because it's the cheapest one. So if we do this one, we might need to embed the cost in there too, but let's worry about that later. So let's try and actually do this. So we've queued up all possible locations. So what we will do is we're going to loop all this later. So now we figured out where to go. Try moving to one of the places. So what we'll do is we'll pop off the queue. So we will grab the first item from the queue. So we will say move equals queue at spot 0. Let's make sure there's something in it. This is just a sanity check for our own sanity. There needs to be something in that. Cool. So now if we have a move to do, we will unset queue at 0. We'll basically get rid of it. I think that works. Oh, this might create a... Does this create a sparse array? It might create a sparse array if we do that. You know what we have to do? I think we have to do this. I think we have to set queue equal to a new array. And inside that new array is whatever queue had. Starting at 1. I think we have to do that. So echo trying move vardump queue. So if we run this, okay, cool. So we're going to try this move. This was what was at spot 0 of the array. Now the array is shifted and we're going to try this move, and that's what the new array looks like after it has shifted. Technically our algorithm is biasing clockwise over counterclockwise. I don't think it matters because I don't think we don't have any sort of thing that tells us one is better than the other, so we just randomly decide which one to do. And by random, I mean we're always going to go left before we go right. Yeah. All right. What are we doing now? We're going to try this move. Okay, how do you try a move? We need to check. I guess we can do loop detection first. Right? We can totally do loop detection. Worry about that later. we'll have to keep track of what we visited in the same direction. But until then, let's actually try this move. What do we do? How do we try it? We have to see what's there. So the character at that spot. What is the move? X, Y, and direction from move. Key equals X comma Y. We're just rebuilding it. Grid at key. If it's... Oh, we can do some checks here, actually. If key is equal to end location, hey, then echo we won. Exit 5, echo figure out the path now, dummy. LOL. Cool, so now we have a win condition programmed in. That's nice. If the key is the end location, then we know we won. Otherwise, we're going to check if C equal to a pound sign, then echo we hit a wall. Give up on this attempt. So now we'll have to repop the queue. So we should just like, you know, to do give up. This is going to be in a function, so we'll like break out of this, or there'll be some sort of loop or something. So now if we're down here, then we know for a fact we can actually just assert this, that C is a dot, because it can't be any other character. This is sort of like an assertion. So C is a dot, so we hit a free space. Let's try moving there. So now that we've hit this free space, we need to go back to the top of the loop. We need to construct all 3 moves we can make in this queue, and this queue needs to embed some information that we care about. Because yeah, there's no way of knowing. We're gonna have to keep track of. Oh, we're gonna have to keep track of so much. But this is okay. This is okay. Let's just do this. Trying move. Free space. Okay, cool. So it detected a free space. That's good. Now we're going to have to put this in a loop, and we're going to have to add some constraints to it. Are you going to try every possible move? I hope not. I'm going to keep track of the prices, and I'm going to constantly put the lowest price at the highest priority of the queue. So we always... Sorry, I don't remember how I said it. The lowest price thing, it's basically, we're going to do like a... Going down from a tree structure, we're going to always prioritize the lowest price move, and when that one hits, that might change what it is. We might, you know, pop certain things off. When that one hits, then we know we've hit the lowest price. I hate this, but it is what it is. Let's just put this in a function called try move. So we pop off a move from the queue. Let's put better error handling here. Okay. I think we just need to do this, right? Yeah, and we'll just break out of this. I can change this while loop to be something different, but for now we'll figure it out. While true, do this. Okay. So if we hit a free space, yeah, we're gonna have to abstract this logic too. Okay, local. Oh no, we'll make a function here. In queue moves. Cool. So we have a function called enqueueMoves, and this function will enqueueMoves based on the, what should we give it? The current direction and the current location. So this will enqueueMoves based on that. So once we yeah, let's do this. I don't love the mixture of functions all over the place. It's kind of annoying, but here we are. I'm going to put all this down here. Cool. Nice, so we just have functions. Good, good, good. Now we will read the grid, print the grid. Cool. Bash into submission. Yo, I'm trying, man. We have our cur direction, our cur location, and we will NQ. Is it spelled like this? Is that how you spell NQ? Yeah, it is. What other languages do you use primarily? Rust and C. So we enqueue moves, and then we call try moves. Okay. We try the move. If it's the end location, we won. If it's this, we hit a wall. And we just continue. And if it's a free space, then we will... Yeah, okay, we're getting here. NQ moves takes a cur direction and a cur location. So NQ moves... cur direction, cur location. Awesome. So then if we hit this free space, then we know that we can enqueue some moves at the dir and the x, comma y. I think this is an infinite loop. I don't think we have enough ways to break out of this. Yeah. Yeah, I think this is an infinite loop. That queue is growing real big. Yep. So we need to do a couple things. We need to keep track of what we visited so we don't overwrite it. But then, of course, every time, let's see, we pop a move off the queue. So we remove it from the queue. That makes sense. Then we try it. And the way we try is we check, is it the end location? We won. Is it a wall? We give up. And if it's a free space, then we do have to try moving there. So the move that we're enqueuing could be the same location that we're already at. And if that's the case and we hit a free space, well, then we have to queue more moves at the different directions. Oh, okay, this is fine. Yeah, this will just spin us and do all that stuff. That's okay. That's okay. Yeah, that's all good. That's all well and good. So what we need to do is we need to store more data than we actually have right here. Let me think about how we're going to do this. Because yeah, we don't want Q plus equal here. Yeah, we want this at the end of the queue. We want this at the beginning of the queue. Because this one's the cheapest one so far. And then we want these at the end of the queue. Because these are the most expensive ones. Cool. And then we need to keep track of the cost to get there. And the moves we've taken. Yeah, I think what we need is a print grid. Should take some arguments, I think. There we go. So now with print grid, we can call it every time we try one. All right, so we can see the greater than signs when we're trying a certain direction. It is walking. It's walking. And then we can see when it gives up. Cool. So we can see that it's walking in a direction and it's prioritizing moving straight over turning. What we need to keep track of now is if I were to let that run, it would make it to the end. No, there might still be loops because what we have to do is we have to check which ones we visited as part of a leg. And then we have to determine when that leg is died. This is tougher than I'm realizing. Yeah, because we're not keeping track of the moves we've made. And we do need that because we're going to need the path at the end of this. I actually don't know how to do that. Let me think about this because I'm imagining a tree structure. Let's do this. We're going to do my favorite thing. We're going to make a simple maze that we can practice with. Cool. Here's a pretty simple maze, right? Let's say we start here and we end here. We won. Cool. But we made it to the end using an algorithm, but what was the path we took? Because let me think. I'm losing it here. I might need to take a small little break. We'll see. When you hit a wall, you can't continue with that path. That path just didn't work. So we don't enqueue anything more. We just try again. But that may have been like, no, yeah, this is fine. This is fine. Let's try this. I'm making something up here. Let's add this to moves, and when we hit a wall, we will remove the last element of moves. Is there an easy way to unset the last element of an array? We're going to learn some bash. A equals foobar baz unset a at index -1. Yeah, okay, cool. That's super easy. So now we can just do unset moves at -1. Can't pop. I don't think there's a way in bash to pop from an array. Not that I'm aware of. Where's the sleep? Okay, so, oh my god, this actually might be right. Starting at 2, 3, we move to the right. Then at 1, 3, 2, 3. No, we didn't move up 4 times. We moved up twice. Wait, you're using a queue? Are you sure it's the best structure for this? No, I'm not sure. Not at all. I am not sure in this decision at all. I mean, I can tell you my thought process. My thought process is, forget bash. I want a tree structure, which is what I want. I want a tree where every node that comes, so we have the first starting point, and then we branch down 3, which is all possible moves we can make. And I want to go down the legs of the tree until we get to a solution where I constantly prioritize moving straight as opposed to turning, because moving straight is cheaper. And once I get to the end the first time, as long as we keep prioritizing the cheapest path, I can just walk the tree up backwards, and that should be the path I took. That's what I want to do, but I don't really know how I'd implement something like that in bash. So I'm doing a couple little test things here. So 2 is this direction. 1, 3. Yeah, none of this is right. I mean, it's right that I went right and then up, but I didn't go up 4 times. That's clearly incorrect. Every time we try a move, we put it onto this queue that has 3 different things. And every time we hit a wall, we have to pop off that move that we made. This seems wrong. Alright. So we pushed on the moves, then we tried to move again, we pushed on the moves, we hit a wall, and we only popped off 1 from moves. Yeah, see, that's wrong. I might be crazy, but I think it'll be good for the future if you nail down the maze solving algorithm. You think being able to solve the maze will help me? I think so too. I think it'll be really helpful if I can figure out how to solve a maze. Shouldn't you clear all of the moves, not only -1 when you hit a wall? Yeah, the problem is we're starting at a given number of moves. So, like, I'm a very brute force programmer, but here's how I'd approach this if I was in a different language. I would make like a struct thing, and in this struct, I would keep track of the X, the Y, the direction, the total cost, and the moves. This is extremely excessive, and I'm sure there are way more elegant solutions, but here's my brain, how I would solve this, which is when I enqueue a new thing, I'm enqueuing the X I'm at, the Y I'm at, the direction I'm facing, what it cost to get there, and all the moves it took to get there. That's how I think of this problem. That way, when we pop this off and we go to enqueue new things, we can add that total cost, we can add it to the list of moves that it took. Something like that is kind of how I'd approach this problem. How do I encode that in Bash? I can do it. I just don't know the cleanest way to do it, or if that actually gets me what I want here. Maybe I just do that. Maybe I just actually do that. Let me think about what that would look like. So we have the current direction, we have the current location, the current cost, and the cur moves. These are all the moves it took to get there. That's just shifting the 3 arguments and then taking all the latter arguments. We're going to brainstorm here. I sometimes brainstorm by writing code, so because none of this code really works in a way that I care about anyways. If I lose it all, yeah, it is what it is. I should probably declare these local, right? Probably should be good about things like that. Okay, now if we try to move forward, we extract our XY from the current thing. Now we need to push something to the queue. And what should we push to the queue? It should be let's come up with a queue format. It would be X, comma, Y, pipe, direction, pipe, cost, pipe, moves. And the moves will be I think that's how we'll do it. And we can separate those by spaces. Might make sense to just do a comma here. XY direction. Nah, let's just keep it at pipes. So now we have to enqueue moves, and the way we do that is we give it let's give it the location, the direction, the cost, these are our starting moves, so nothing cost anything yet. And we have nothing to pass as optional arguments. We're gonna clean this up as we go. Location and direction. And then when we're up here and we have to enqueue moves, we do the location, the direction. Okay. We have the queue. And the queue format is this. So we need to break the queue into that format. Okay. Yeah, let's just use location consistently. All right, so we have all this data encoded in our moves. Location, direction, cost moves. We print the grid, we sleep, and then we check if it's a wall. We don't need to do anything. If it's a free space, we need to queue new moves. All right, so this will be a string of all the moves, and then we're going to turn it into an array of all the moves. And the reason we're turning it into an array of all the moves is so we can pass it back here. This is all we care about. And then if we hit a wall, we give up. And then if we care about this, oh yeah, we've already dumped moves. This should have everything we need. Okay. Okay. Now for our queue problem. What we need to do is we have this. So when we put it back into the queue, we need the queue format. The move here will be the X, comma, the Y, pipe, the cur, direction, pipe, the cur cost plus 1 because we moved forward, pipe, all of the moves that we were given. So cur moves separated by spaces. It's a lot of data to embed, but I think we'll be okay. And then we put this at the beginning of our queue. So now we're down here. We have the X, Y. We have the cur location, the next direction, the cur cost plus 1,000 and all the moves. And then we put it at the end of the queue. And then we do the exact same thing down here. And then we've enqueued the moves. We still don't have any logic to check if we visited a place. I don't know where that's going to fit in yet. All right, well, our enqueued moves are clearly wrong. Oh, yeah. Okay. What am I doing wrong here? Cur direction, cur location. Oh, am I doing it backwards? Yeah, we passed the location, direction, location, direction, location, direction. As long as we're consistent, we should not run into these issues. Okay. 1, 3 with no direction. Yeah, that's not great. Okay. Well, it's counting up the cost. So that's something. And every time we in-queue something, we need to keep track of our current moves. That got pretty big pretty fast, huh? What was the total I needed, actually? Oh, the lowest score is all I actually needed. I didn't need to actually keep track of the moves I made. I might leave out the current move logic for now. Yeah, I might do that because I technically don't need to keep track of it. Yeah, the direction is doing something wrong. Yep, okay. Okay, cool, we won. Let me solve this by hand and then figure it out. So if we have here and we start going east, the cheapest path is to go east, turn counterclockwise once, go up, and then hit it. So 1,000, 2, 3. So 1,003 should be the answer, right? So when we win, when we are here, we have all the moves that it took to get there. We just have the cost, right? Do we just echo? Cost points? Is that it? $100,000, 1,003 points. Okay, cool. Okay. Okay. The first example, 7,036. Okay, so 7,036. This might take a long time to run. I might have to get rid of some prints and stuff, because I think it does, like, sleeps and stuff. Yeah. Let's go ahead and clean that up. Yeah, let's not var dump the moves. Okay. And if this works, the answer should be, what was it, 7036? 7036. So you can see the numbers kind of counting up. Oh, we don't have the visited the same thing logic, so I think we are going to get stuck in loops. Right? I think we are. Yeah. Maybe. Now we're at 6,000. Will this detect loops? I guess. I'm trying to think. I'd have to think about loops more, but like the way it's prioritizing it, I feel like it shouldn't. I feel like it shouldn't. I don't know. I don't think it's ever getting to 7036, is it? I think we got ourselves into a little bit of a loop scenario. How would we detect loops? We have to check if we visited the same place at the same direction, but we have to check if it's as part of a thing. So maybe we do have to keep track of all the moves we've done as an X, Y, dir thing, and then read them into a... I think we do. I think we have to keep track of the moves we've done, embed that information. This is going to get so big. And then we need to read it into an array. You know, we're being really good about passing variables. I don't think we should. I think we should use global variables. They'll be significantly faster. Cur location, cur direction, cur cost, cur moves. Yeah. Yeah, and then we check. Check if we've been here before. The way we do that is we will read. What I want to do is I want to take this array of moves I've made, put it into an associative array, and then check if the key exists, but that seems stupid because it's just O of n to load it in anyways. So I wonder if I could just loop over all the moves we've made. No need to keep all the moves. You only need to check if you visit it with the same price already. Hey, that's a good idea. I appreciate that. Also, I will say, please do not give me hints. I do want to figure it out on my own. If I ask for hints, I'll appreciate it, but please don't give them to me. I'm not mad or upset with you. Don't worry about that. I like to throw that out there periodically, and I realize I probably haven't said it this stream. So yeah, I appreciate that. And I'll probably end up doing something like that, but I think I'm going to try and do what I'm going to do, and then I might come back and revisit it as a solution. But yeah, thank you. Appreciate it. But yeah, I'm trying to figure out this without any hints. Well, this is going to get unruly, isn't it? This doesn't look right. Oh, yeah, it's because this is too much. Syntax error. I think it's slowing down as I get moving more. Yeah, storing every move might be inefficient because we have to do an O of n scan every time. This might fall apart on the real input. Totally possible. I don't even know if this is going to work, so. We'll see. If this hits 7036, it should win. Is it even making progress? Oh yeah, we're going up. I wonder what's even taking a long time. Alright, well, that's going to take too long. Yeah, I think embedding every move is not ideal, but it shouldn't be that much. It really shouldn't. I'm trying to think if we can come up with a format for the moves that's a little bit cleaner. Let me think about this. Well, yeah. This is too much. This is absolutely too much. What am I doing here? Yeah, wait, what am I doing? I was doing two things. I was doing like... Yeah, that was growing exponentially there. I'll say it. I imagine it will slow down as it gets bigger, but it should not have been going that slow at that juncture. I do wonder if the prints are slowing it down too. Is it even making forward progress? Can't even tell if it's making progress, to be honest. Oh, we got to 6,000, so I mean, it is making progress. Like, definitely making progress. Yeah, the prints slow it down, especially having to format the string, but like, I'm not blasting the terminal with output, so I can't imagine it slowing it down that much. Treating it like an array might not be the best thing. It may make sense to just treat it, to just put spaces between it and treat it as a big string and search within a string. That might actually end up being faster than doing this array manipulation. So this is a maze solver? It will be. Yep. Printing to a file would make it faster? Maybe. I don't know if this is actually slowing it down, because it's printing fast, but this is not as fast as a terminal can print. Like, it's fast to me, but it's not. Like, I think the computer's going to handle it just fine. There can't be this many moves. There can be this many moves. I don't know why I said that. It's doing everything it possibly can to avoid turning, basically. Oh, I'll let it run for a bit, and we'll see. I feel like it's going in circles. I thought that way too, but it got stuck in the 4,000s for a bit. It got stuck in the 5,000s for a bit. Now it's in the 6,000s. I think I'll give it some time. It might go to the 7,000s. Yeah, exactly. It is a tree. It's a tree, and it's going to get bigger with every move. So I can think of ways to make it faster in Bash by just abusing string manipulation as opposed to array notation. And if we have to get there, we have to get there. But, oh yeah, it's definitely making progress. It got up in the high, like 19, 18. Yeah. I can get rid of the trying to hit a wall this attempt log line, and we can at least just see the numbers. Yeah, look at that cost. The cost just hit 20, 6,020. So it's getting up there. I was distracted for a bit, but string manipulation in Bash is faster than arrays. Depends on what you're doing with them. I'm searching over an array piece by piece to see if an array contains something. I have a haystack array and I'm looking for a needle. It might be faster to just have strings separated by spaces and check if the string equals it. Because the way Bash will handle that comparison will be faster than having to loop every element. Because even if I'm looping every element, it's calling Bash code for every element. Whereas if I'm just doing string manipulation, it's going to be like one single Bash thing that's being called. So the underlying C function will handle the stir comp and it should be relatively fast. That's a bit mad. Yeah, it's like if you're in Python or something, sometimes it's faster to give an entire array to a function if the function's implemented in C, as opposed to looping over it yourself in Python code. It's a similar concept. Even if this works, it's so slow. Like, this is so incredibly slow. Yeah, looping is usually slow in scripting. Yeah, exactly. It is. We're done. Okay. Let's get rid of that array. space, location, comma, direction, space. How do you check if a string's in a string in Bash? If I have like haystack equals hello world, hi there. Can I just say like haystack equals star space hello space star? Yeah, as a YouTube chat. Yep, I'm dual streaming on YouTube and Twitch. So it doesn't match. There's a way to do what I'm trying to do. Does not equal that. Variable name is wrong. Thank you. You don't like Hacks Day? Would be nice to get a merge chat and that nice blank space above your head. I agree. I 100% agree. I 1000% agree with you. This stream is a little bit scuffed and it's slowly coming together. I'm relatively new to live streaming, so. Variable name is still wrong. No way. Hack stack. Dude, I'm just making things up. Thank you. Yeah, I might have to do a regex. That notation is for regex specifically. It's this. This is the correct notation. Now I just have to remember things like, I don't think the space is valid. I think if you put it in quotes, it doesn't work. Yeah, so what I have to do is I'll have to do this. So I'll do like A equals hello. And then I can do star space $A in quotes space that. There we go. Good. That's correct. This is the notation I was trying to invent. Cool. Cool. Star, space, space, star. If moves equal that, then we've been here before, don't try it. Now we have to go to the part where we enqueue them. We'll start it with a space, and then plus equal that with a space. No, space at the end because we already started with a space. Okay, we should be good. Now, what's this going to look like when I run it? Seems a lot faster. We're already at the 5,000s. Seems crazy slow. Am I wrong? Like, this seems crazy slow. This is part 1. Like, way faster than before, but it still seems like wildly slow. It's definitely making progress. See, it's like stuck in the teens, then it backed out. Okay. So once we start backing out, we should get to the 7,000s, right? Can't even do the example input. This is crazy. Your Vim cursor moves so fast, are you just holding HJKL? Yeah, pretty much. Most of the time, yeah. I just have a really low keyboard delay rate. 3 a.m. in Spain, I'm watching a bash script going crazy to find the right path. This is so fun. Yeah, I'm glad you're enjoying it. This is crazy. This seems crazy. This seems actually crazy. Nice thing is every time we get back to 6,000, you know, it's like starting a fresh path, so... Did you see AOC in sequel? No, I have not. That seems wild. That actually would be the case. Yes, Dave, we were really drunk watching his watch party. Yo, welcome. I'm glad. 4 a.m. in Finland? Yo, what's up, what's up? 4 a.m. in Egypt? Dude, I got viewers all over the place. That's sick. I love it. Welcome, welcome. Oh, man, there's a watch party watching me watch Bash. What a wild concept for a party. What's up, watch party? Dude, this sucks. It's going to take 8 years to run. 9 p.m. in Canada. That's awesome. I have no idea when this could even possibly finish. Is it even coming close? This is example input. This is the first example input. So like this is this is not boding well. Yeah, if I had to guess, I think that logic to determine if we've been to a place before is problematic, because every time we go to a place we keep track of it, and I think we need a better heuristic for that. Oh, we're in the 7,000s now, so 7036 is what the answer is. So if we get to 7036, it should just be it. I mean, we already know what's the answer. Hint time? It might be. Not yet. I have a couple tricks up my sleeve, but it might be. If my wife wakes up now and sees a terminal on loop and a piano playing, it's going to be so confused. Yeah. Yeah, because it's tough. My brain gives me a bunch of things. My brain first sees it like a tree structure, starting from the beginning, going to the end, and try to come up with the best path based on priority. And the priority would be like, I mean, I've done problems like this. Dijkstra's algorithm, certain roads cost less to run on than other roads, things like that. The other solution is just solve the maze. Find every possible solution to a maze. I don't know how many there are. I don't actually know. A star, algo, and graph tree. I don't know what that is. That might be the answer. If it's the answer, don't give it to me. Like I don't want hints. If I want a hint, I'll ask for it. I don't want people backseat driving, but I don't mind like throwing out like possible solutions. But if you give me the answer, I don't want that. Are you streaming on YouTube in addition? Yes, I am. I'm on both YouTube and Twitch. Yep, so I was just responding to a YouTube chatter. I do want to get like a unified chat up here on my stream, but as of right now, I don't have anything like that. But I would like that. The other thing... Okay, we're done with the solution that I came up with. I'm not going to pursue this any longer because I can see how every time like it just keeps getting worse and worse. We could parallelize this solution. That is a possible thing that can happen. The solution can be parallelized. Just an FYI, totally a thing that can be done. But I'm trying to think. Because we can go through and solve the maze every possible way. And then just calculate what every solution cost. I'm not going to do it, but if I rewrote this in Rust and put some parallelization, I could probably come up with an answer. Because I think the bash solution's pretty close to an answer. An answer on the first example, which was like super simple. So it's not above my ability. Like there have been times where I've stumbled into the math solution, which seems crazy, but I've just invented patterns and they sometimes work. So I won't rule that out as a possibility. I do want to see this solution finished though. Let's see. In my other window right now, I'm just staring at the maze, hoping for divine intervention. So I'll talk out loud. I'm looking at the maze here, and I'm just like thinking of things like, because in this maze, the first thing you have to do is you turn, and you have to go up here. I'm trying to think of ways that we can describe this problem. Like, I know what the inside of the maze is. I can count how many free spaces there are and how many walls there are. I don't know if that helps me, but these are numbers. I'm basically making a list of variables I have, so I know how many walls there are. I know how many free spaces they are. I know my distance from the start to the end. I could calculate that. So I could calculate an X to the start, an X to the, like an X from start to end, a Y from start to end. I don't know if those help me at all. So I could figure out like what the actual price is. I could also do a very simple algorithm of like try to take the ultimate path and then work my way backwards. So for instance, if I'm here, the ultimate path would be to go up and then to the right. Also, the ultimate path would be go all the way to the right and go all the way to the end. Like the claw machine, very similar. So basically the ultimate path would be this, and then what I could do is I could start straying away from it. Like, oh, this path failed me because there's a wall. But I'm just describing the pathfinding algorithm I already wrote. Like, I'm just going to end up in that same scenario again. Yeah. Let's see. Have you marked the visited nodes where you have gone through all 4 directions? Kind of, yeah. Each direction I look at keeps track of all the moves that it took to get there, so I at least know if I'm backtracking. Couldn't you get the wall coordinates and pre-mark them as no-goes? I have all the coordinates, yeah. I loved at uni using the dead-end algorithm for maze solving, but if there are multiple ways that, yeah. I know, I'm trying to think of... What I'm doing now is I'm just trying to imagine different ways. By the way, the terminal's still doing its thing. As you can see, it's definitely slowed down. Because this is just, what is this? The name is this recursive backtracking? Is that what I'm doing? I think that's the name of this algorithm. But don't quote me. I'm a sysadmin. My CPU temperature is going to be fine. This thing is going to be maxing 1 core. Yeah, it's just maxing 1 core. My computer has enough cores, and this is a Mac Studio, like M1 Ultra or whatever. It's like the top of the line Mac Studio from 2 years ago. This is going to be so overpowered for what it is. I'm not distributing this workload across the cores. Yeah, so I'm not gonna have to worry about that. Let me think about how I would solve this, because we don't need to keep track of the path. I'm only thinking about part 1. I'm not even gonna think ahead. We don't need to know the path. We need to know the lowest score. That's it. That's all we need to know. It's the lowest score. So I'm trying to visualize this problem differently, like, because I'm thinking of X and I'm thinking of Y, what it takes to get there in the X and what it takes to get there in the Y. And I'm wondering if that can help me at all, or if it makes sense to not do that and just draw a ray directly from the start to the end. And then, I don't know, I really don't know what I'm doing here. Let me think. Because I've successfully written the algorithm I wanted to write. I think I can improve it by keeping track of the moves that we've made. Instead of doing that, we could just keep track of the places we've seen and the cost it took to get there globally, and it would probably be significantly faster. Let's try that. You know what? We're going to do that thing that I always said I was going to do, but I've never actually done. We're going to open up a new terminal, and we're going to try this while the other one still runs. CP part 1 to part 1 new. Also, if you are watching on YouTube, go ahead and hit that subscribe button. When that number goes higher, it makes me feel good. So go ahead and do that. Everything is keeping track of its own set of moves, but I don't think we need to do this. I think we need to keep track of the cheapest moves. So declare globally, declare -a cheapest, And then when we enqueue moves, we will do scrolling FAQ in the free space above your head. Hey, that free space will become a unified chat, hopefully. What was my plan here? When do we know if we have a good move that we're going to move on from? The cheapest move is the first move. I have to think about when to store into this. I think it's wild. Bash allows for functions with hyphen in their name. Yeah, bash functions are pretty much just like commands on your system. You can pretty much just put hyphens there. I like it that way. When do we record it? If we enqueue it, if it's a free space, then we will make the assertion that it was the cheapest place for us to go. Cheapest, loc comma dir, equals 1. If cheapest, loc comma dir, if dash n, that, if it's set, then we've been there before. We don't need to try again. No, we need... We might need to do some store the cost as well, but let me just think about this. Yeah, there's no reason to do this. Part one, new. Command not found. Command not found, but I got the right answer really fast. I got the right answer very fast. That is the right answer. Where did I try to run that? Oh, pfft. There's an example where Vim thought it was right, but it wasn't. 7036 is the correct answer. Oh my god. Okay, so for example 2, if we run it, it should be 11048. You did it. I did it. I may have done it. We're going to see. 11048. That's so much faster. What was I doing? I just need to make the assertion that when we got there, it's the cheapest, and then we store it. So we never want to revisit that space. Yeah, that's so much simpler. Oh my god. Well, we did it. Hey, we raced the thing in the first terminal and we won, right? I know you say it's probably looping. I don't think it was looping because it starts in the 4000s, works its way up to the 5000s. So I think it's just taking exponentially longer each time. Yeah, part 1, new, read in from example 2, 11048. Hey, I'm just popping here to see if anyone has seen my wallet. What a wild thing to say in the chat. If you follow up with any sort of cryptocurrency scam, you're getting kicked. We're going to run on the real input. Okay. This doesn't seem painfully slow. Maybe it is. I don't know. Okay, good. Thank you. It wasn't a cryptocurrency scam. I get comments like that on my YouTube sometime where it's like, hey, you know, I have a wallet on this website and here's my seed phrase, and just dumps an entire seed phrase. I'm like, I don't want this. Like, I don't know what this is. I don't know what kind of scam this is. Get out of here. Now without echo. Yeah. We might have to remove the echo. It's true. Cool. It finished. It actually finished. Oh my god. How big is the real maze? Great question. The real maze is 141 tall and 141 wide. 142 because it counts the trailing new line. But yeah, 141 by 141. Oh, it looks like. And if you run it without standard out, that's what people are saying, without the echo. Yeah. We can try it. I don't mind just letting it run, so. So if we do that, what we can do now is we can call time on it, and we can get an idea. I mean, it prints the initial maze, but like, who cares? So I'll just let that run in another window, or I'll leave it open because I'm not really doing anything here. Oh, did I just get rid of, I think I just got rid of the score, didn't I? No, I didn't. And besides, it's going to generate it again, so it's not the end of the world. $105,508. Cool. Let's go ahead. While that's running, I'm going to put that number in here. You guys ready? Let's see if this works. Oh! What is this? I've never seen this. That's not the right answer. Your answer is too high. Curiously, it's the right answer for someone else. You might be logged into the wrong account or just unlucky. Okay. It's too high, though. That's interesting. Very interesting. Whoa. Okay. Okay, check this out. That's cool. So this took, oh, you can't see it. To run without the echo, it took 1 minute and 44 seconds, and most of that was in user time, so that's just crunching away at code. Was this the one I put in before? I'm just gonna input it. I'm gonna input it again just to make sure. You gave an answer too recently. You have to wait after submitting an answer before trying again. You have 2 seconds left to wait. Oh, so you can't like brute force it? Okay, cool. I wasn't even trying to. I just never came across that. 105,508. Just want to make sure. Okay. That's what it's giving me. It only takes about 2 minutes, so I'm going to go ahead and recopy over the input just to make sure that it's not an input problem. You know what I mean? Okay. So we're running it again just to make sure that I didn't get my input wrong or whatever. So I hope it's not like some sort of off by one thing. I don't think it would be. I'm gonna look at my real puzzle real quick. Oh, this is terrible to look at. What I wanted to do is look at my real puzzle input and see what the end of it looked like and then recreate that in a simple example to see if maybe my final step logic is like off by 1. I don't know if answers would be that close to each other. It's weird that I got someone else's answer. Are you stopping at the first solution? Yeah, I should. There's just a call to exit in there the moment I have one that works. Yeah. I always find bash courses useful because there are some things I forget over the years. There's so much to learn. Yo, it's true. There's so much there. Yeah. 105,508. There may be a shorter path. Well, the shorter path doesn't matter. It's just the cost of it that matters. Yeah, we've been here before. Don't try it. If the location is the end location, then we won. Yeah, there's nothing to process anymore. We know the cost. We know what it took to get there. I'm going to try and open up the input on the terminal. Okay, cool. So mine's here. I don't know if you can see this, but like this is where the end is. So it does have to go up into the end. Oh, but it had to do that in the other example too. The final example did that. Yo, what a crazy puzzle. Dave, is your code working on the sample input? Do you get the right answer? Yeah, I do. It is working on the sample input. That's why it's confusing. There were 2 examples given in the advent of code. This example, which yields 7036, and this example, which yields 11048. So when we run part 1 new on example 1, we get, it should be 7036 when it's done. It needs to read in from that file. 7036, and then this one should be, what, 11048? Yep. They both work just fine. So it's just the real input that does it. So that's what stinks. So this works. This works. If you visit a coordinate and mark it as visited, what if you could get to that coordinate via a cheaper path with less turns? Try running it starting with a different direction and see if it changes the output. That's a good idea about biasing a different direction, but the cost... I think you're onto something. Because I think the cost, I think I'm just getting there. Yeah, I think this is, yeah. Yeah, Ivan was saying this in the chat as well. I think there's something... Let me think about this. I feel like it does require solutions, yeah. If you throw a wall directly west of example 2 input end, then it'll match the ending of your real input a little better. Take example 2, you can go straight to the top or make the first right, the two paths with different costs. Yeah, so I'm going to try and come up with an example where we exit early because we got an answer, but it wasn't the answer. So in this example... How can we let me think of how to contrive an example. Yeah, let me try and think of how to contrive an example that gives us that kind of thing. Because what do we bias in the code? We bias clockwise. We check clockwise first. And we always start going east. So if we do this, can you change the endpoint of the real input? Yes, you can. I can, and we'll get different answers. But yeah, I can just move it wherever I wanted to, if that's what you're asking. What do we check? We check clockwise first. If I do that, I should have 1, 2, 3, 1003, 4, 1004, 5. It should take 1005 to get there. 2000, no, 2005, sorry, I said 1005, I meant 2005 because it takes 2 turns to get there. That's right. Same as down here. Yeah, that works. Yeah, Alright, let me look through. Ivan said something. Take example 2. Take example 2. You can go straight to the top or make the first right. Two paths with different costs. Optimal only takes 1005 and extra wall case upright. I don't know what you're saying. In the Twitch chat, in simple that text wasn't the cheapest. You have to turn first. Your character always is moving east, no matter what. You start off moving east, and so if you want to turn at the beginning, that costs you 1,000 points. So, yeah. So, like, I'm gonna start moving east here. If I have to turn up and then turn right, that's 2 turns. So we're at 2,000. If I move up and then right, it's still 2 turns. Optimal only takes 1005 in the extra wall case. No, it shouldn't. Like, yeah, sorry. Actually, okay. Both of you are saying this and you're in different chats. I really need to get a unified chat right here on my stream. But yeah, you both nailed the same thing. Yes, your character is always moving east. That's the downside of this. Okay, I think I have an idea. Because of the way I coded it and the way I've coded priorities, when we jump up 1,000, our code jumps to different levels. So I think once we find the solution, we need to keep finding the solutions until we jump to the next level. So like if we're in the... okay, this sucks because it breaks. We're going to keep track of how many turns. How many turns have been made. Hear me out. I don't know if this makes sense. No. They just happen to be 1,000 apart. Doesn't really matter. I don't know if this is a good solution, but let me think about this. Yeah, we keep track of Kerr moves. I think we're gonna overwrite Kerr moves to be num turns. This is ridiculous, but just trust, okay? This doesn't really work because technically I could just move 1,000 spaces and it's the same cost as a turn, but because the way I'm currently doing priority, I think it's okay. This sucks, guys, but just bear with me. Okay. Okay. Something. Yeah, wait, this solution right here. Look at this. Go all the way this way, turn, go up, and that's 1,005. But you could also win by going up, turning, and going back down. Yeah, okay. So once we have a winner, we push them into here. If turn's greater than last turn. Yeah. Okay. 70-36. Okay, there was one solution. Okay. You should associate the winner printout with the starting position so you know which one you're getting. Well, they're all going to start in the same... They all start at the same exact spot. They just take different paths to get there. Ah, the initial turn, yeah. I could keep track of their turns or something. It's the same answer, isn't it? No, I'm not brute forcing all possible solutions. I'm not doing that. Yeah, 105,508 is the same answer. I don't understand. And that's the only one I could find at that level of turns. Like, I realize I probably have the right puzzle, and I probably have a bug. I know it's gotta be on me, but like, that's crazy. My answer is too high, and it does match someone else's. Like, something's really interesting about that. Are you prematurely quitting before you try all directions? I might be. I have no idea. I don't think I am. I shouldn't be. All I do now, instead of quitting, is I just append them to a winners, and then I try again. So I pop off the new one, then I check if the number of turns in that solution is greater than the last number of turn we've looked at, then we know we're on the next level of the tree, effectively. Which, of course, something. Curtains. Yeah, this should be fine. Yeah, it seems bad. It seems bad because I'm always biasing clockwise. So the first turn is clockwise, and then we build off of that. Will we ever go back and recheck the clockwise? Like, once we get the winners from the first thing, should I go back and try to... I don't know. Because we're done at that level. But no, we should never move on to the next turn until we've checked them all. Okay, I don't want to resize the window. I want to grab the scroll bar. We just have it stored as an empty string. We got lucky that Bash treats empty strings like zeros. That. The only thing I can think of is that we do bias. We absolutely do bias clockwise over counterclockwise. I don't think that should matter. But it might. It might matter. So this could potentially fix it, right? It's totally possible that this fixes it. I don't know if it will. Yeah. Can we see the code with the visitor stuff again? Yeah, I'll pull that up after I let this thing run. I also haven't been fully paying attention, but I think you already did one of my hints, and the other hint probably won't fix the bug. Okay, fair. Yeah, I think that's what I'm encountering is I think I'm encountering a bug. Like, that's pretty much it. My current hypothesis, for anyone paying attention, is that my bias of clockwise is bad, so I've just changed my bias to be counterclockwise now. Let's just see if we get a different answer. That's literally all I'm going to do. If I do get a different answer, then my logic needs to be updated. Why is it running so slow? Limited by terminal output? Listen, if you weren't a first-time chatter, I would kick you for saying that. Not really. Because you're giving Warforged some ammo to use against me. It's slow because I'm writing it in Bash. That's really what it is. I need to optimize some things around that. I don't think the echoes are slowing it down that much. We'll see. I have the timing output statistics. Hopefully it's not. But I'm trying to imagine what I need to do. We need to contrive an example that tests my counterclockwise versus clockwise biasing. Standard out is expensive. Listen, man, standard out is a file descriptor that is available on Unix-like operating systems. It's not expensive or inexpensive. Each print is a syscall. Hey, that's better now. I actually don't know if that's true. Yeah, it would be. Echo's built in, but I don't think it does any sort of buffering by default. Don't just say it's true. Actually think through the problem. It would depend on how Bash is implemented. I could understand. I could believe that, like, it's like calling printf and C. Okay, I got the same exact answer, so something's not right here. But yeah, it'd be like calling printf and C. I call 3 printfs. I don't necessarily get 3 syscalls unless I change the standard out buffer. I didn't time it, so we didn't even know. There's buffering somewhere. Great, cool. 105508. This is the same answer. I keep getting the same thing. Like, this isn't right. It's not Bash as slow as the terminal, I think. Listen, okay. I understand. I understand. I'm not yelling at you, first time chatter. You're fine. I'm going to yell at Warforged. Warforged is my friend IRL. I'm going to yell at him because I know he can handle it. And he's a good guy. He actually is. I swear this. I'm going to yell at him because he's my friend and we've known each other for a very long time. Writing to standard out and having it show up on your terminal is an expensive operation, especially if we're going over SSH, where now it has to go over the network. Yes, this is expensive. This is moving fast. It might have an effect on my timing, but I don't think the timing effect is going to be as big as you all think it is. I think it'll still be within the realm of a minute. So yes, it makes a difference, but I don't think it'll make that big of a difference. We will see what the difference looks like. I will run it with and without the echoes for you all. Now, it might make a difference. Well, hold on. I owe you a lunch. Listen, I'll buy you a lunch either way. But I want to know how different it will be, because I think it will make a difference, but I think it's going to be in the realm of like a minute. I don't think it's going to be that crazy of a difference, but maybe you all are worried about that difference. So we shall see. So yes, random chatter. I'm not yelling at you. I am yelling at Warforged and Warforged specifically. But we shall see. I'm just going to let it run. At least you're consistent, even if consistently wrong. Yeah, exactly. Thank you. I appreciate it. If we're saying 1 minute compared to 3, it's like a 33% hit. Can't math. I'll let you figure out the math. I think when I ran it without the echoes, we were at about a minute 45. But in my mind, I'm thinking of the difference between like 1 minute and 10 minutes. So maybe I'm just like in the completely different realm. Okay, look at this. 1 minute 55 with the echoes. 1 minute 55 with the echoes. 1 minute 48 in real time. 5 seconds stuck in the system, probably writing to the screen, right? Right? Right. Commenting it out. We're going to rerun this. 1 minute 55 is the number to beat. I'm not going to clear the terminal. We can scroll back up and see it. 1 minute 55. I think when I ran it before, it was 1 minute 45. We're talking 10 seconds here. Now, you can say that's significant. I'm not going to poo-poo you for that. But Warforged, I don't think this is having the effect that you think it's having. So I expect that lunch, and it will be delicious. To be very clear, I know very little about the implementation of printf and C standard library, besides that it does some kind of buffering and some amount of syscalls when it actually wants to help with the data. Yeah, you'd have to look into the specific like implementation details. From what I know, it does buffer until it hits a new line, and there's a couple ways you can get around. It's like vset buff or something, I think is the function. You can also flush standard out. Standard error is different. Standard error won't have any buffering by default. But yeah. Does bash spin up a new process for each line it's running? Depends on what that line is. If that line's a function or that line is a bash built in, no. If it's a command, like on the external, like an external command, then yes. Yeah. Oh, but yes, like if you're in a C program and you're printfing to standard error, it's different than standard out when it comes to buffering. So yeah. Okay. Warforged says, okay, I can concede that perhaps bash is the bottleneck here. We shall see. We shall see. It potentially forks many things per line. That's very true. If you have external command, pipe external command, pipe external command, it will fork all three pretty much at the same time. Not one after the other like people would think. It forks them all and sets them up before they even start running. So you fork and then you connect everything and then you exec. So it's a little bit confusing for people. People get into race conditions without realizing it. It was 0.19 for sys previously. Hey, that makes perfect sense. Yeah, because we're not outputting to the, like once we start printing, we're in the syscall land. So we're going to be using system time there. Piggy is right. You do have to print a new line to clear the buffer or use the flush function or something. Yep, exactly. 1 minute 53 with 47 seconds in, because remember, this one is using the counterclockwise bias, so it might be slightly different. So do we get a minute 53 there? And if we scroll up, a minute 55. So a 2 second difference. Warforged, this is what you're talking about. See, this is what I'm saying. When I'm watching the terminal, I'm telling you, my instinct is kicking in. It's printing fast. To a human, that's very fast. But I know that it's not bottlenecked on the terminal. I can just see it. I've seen it go faster. I know that that's not the bottleneck. So that's a 2% hit. Is it even a 2% hit? It's like a 1% hit. Get out of here. 2 seconds, that's an eternity. Oh my God, you guys are funny. Listen, I expect an apology from everyone in this chat. Yeah, this literally is a margin of error. Like, I could probably rerun this and get a different thing. Like, you guys are ridiculous. Either way, we are consistently getting 105,508. And that seems to be somebody else's puzzle answer, which has me concerned. Darn, you know, I'm tempted. I'm not going to, but I'm tempted to pull someone else's solution code, like someone's solution code that works, run it through my input, and verify that the answer is not 105,508. If I get a different answer, then I know that my solution has a bug. Just because it feels so strange that I'm getting the wrong answer consistently and it's someone else's answer. Yeah, it's not just the wrong answer. I actually got a mess. I'll show you the message I've seen. I've never seen this message before. If I go here in Advent of Code and I type in this answer, not only is it not the right answer, curiously, it's the right answer for someone else. You might be logged into the wrong account or just unlucky. So how weird is that? Like, that's weird, right? That's super weird. Have you tried logging out and logging back in? I could. Can you add turn count to the visited array and see what happens? Yes, I can. You just want to see the right answer then and work towards that? Yes, that would be my goal. I don't even want to see the right answer. I just want to, like, give someone my real input, have them run it through a solution that we know works, and to say, yes, Dave, the input is different. Your solution guaranteed has a bug, because then I would feel better about it. Yep. Here's what I'm going to do. I'm not going to log out and log back in. I'm going to look at the visited stuff. Maybe the answer space possibility is small, so it's just a coincidence. I feel like it's got to be just a coincidence, yeah. Because, I mean, this answer is only, 108,000? That's a small number in terms of 48-bit integers or whatever Advent of Code uses, so it's totally possible. Where did I keep track of my visited? Scene? Great, I don't name them. This is what I got. Cheapest! Okay. We have the location. We have the direction. That's what we store. The location, the direction. Maybe we should store turn count in there. Because maybe we're filtering out things that we shouldn't be doing. Oh, sorry. My bad, everyone. Here's the terminal. So what I did is I pulled up my code. I tried to find where I kept track of where I've seen. And of course, I call it cheapest. Because that would be too easy. Let's do this right now. And what I was storing before was the location and the direction. Now I'm going to make the key the location, direction, and the number of turns. I don't know what a bad streamer. That's correct. I don't know if this will change things. That is the same answer. That is the same answer. It did take a little bit longer to run, because it has to try more possibilities. So this one will take longer than 2 minutes to run. So there is that to be mindful of. I'm going to let this run. I'm going to go grab a drink. I'll be right back. Darn. You know what I wish I had in this solution? Echoes. I really wish it was printing to the screen. They're basically like net zero when it comes to performance costs. So like, I would really benefit from them right now. You have to be a masochist to do this in Bash. Listen, you're not wrong. Go check out my YouTube channel. I've got oh man, I've done the first 15 days in Bash. I am here for the long haul. I do everything in Bash. It is insane what we do here. What we do here at You Suck at Programming with Dave Eddy. Did you know you could buy this on a t-shirt? I have a bunch of other t-shirts. I have a t-shirt that says, "You wouldn't exit Vim. It's not possible." I love that shirt. It's all on my merch store. ysap.sh/merch. Did you know that? You guys ever see my website? Well, it would help if I typed my website incorrectly. Dave, you're not sharing your browser. Okay. Here's my website. You guys ever seen this website? This website's sick. Why is... There we go. This browser could be a little bit bigger. Let me... Hold on. Dev, YSAP tools, horizontal. Okay. There we go. I have a script that resets my terminal sizes and my browser size. Yeah, this is my website. You can curl it and it looks almost exactly the same. Did you download your website, or did you write your website in Bash? Yes. Unironically, yes. Go here. The source code is here. You can see exactly how I make it. There's a /website directory. This is not a Bash web server. Nope, this is served out of Nginx. But yeah, you go here, there's a link to the merch, Instagram, YouTube. Click the merch page, and you can like, you wouldn't exit Vim, you suck at programming, YSAP. Yeah, it's a little cute little book. Yeah, we got merch up there, so go ahead and check out the merch store. Merch store is actually pretty sick. Let me pull back up the terminal for y'all. All right, you wouldn't download a car. Exactly, it's modeled after the you wouldn't download a car. You get it. Yeah, Bad Cop is another creator on here on Twitch. I think her name is Bad Cop with an underscore after it. She does Bash. I've actually raced her in a couple Advent of Code puzzles. She's very smart, so it was a tough race. She ended up destroying me at one point. We're going to cancel this. 8 minutes. Oof. We're going to cancel that. And we're going to do some echoes. And we are going to do that thing where instead of storing the turns, we're going to set it equal to turns. Because we've been here. Let me think. We've been here with like 5 turns. And then if we go there at 6 turns, then we know that that is not the ideal place to be. So... this or nah. So if n is set and n is greater than turns, no. N is less than turns, then we continue because we've already been there before. Let me think about this. Because if we've been here before at a lower cost, we don't want to store this one. Yeah, it shouldn't be turns, it should be cost. If we've been here and we've been here less than the cost, then we don't care. You may need to flip the less then. I may need to. Also, yeah, if you all are new here, I just want to show you guys what happens here. While that's running, you get this. We're at 21 turns, and we know the answer was like 105. Now, 105 was too high, but I'm just wondering if we could speed up some of this stuff. Like, we grab this here. We can just default it to a really high cost, like something that we're not really going to hit. This might be slightly faster. Nah. How'd you move your camera that fast? I got a button. My camera's on a little gimbal thingy. It's an Instalink 360, so I just click a button. Boop. Like this. Boop. Whoa. Whoa. I could fork and parallelize it. Absolutely. I think I've broken a record. 74 watching on Twitch and 39 on YouTube. Oh my god, thank you everyone. That's over 100 viewers. That's crazy. I've never had viewership like this. If you're, actually, this message goes out to everybody. I have a YouTube. I upload videos regularly on it. I try to hit every day, but not necessarily. Really good information about Bash. I have a series called You Suck at Programming where I just jump right in and teach you something you've never seen in like 3 minutes. I also upload very long form content where I'm like building something from beginning to end. These VODs go up there, and I also cut out parts like this to just have like the Advent of Code stuff if people are interested. So go ahead, subscribe to my YouTube. A lot of good stuff going on there. If you're on Twitch, go ahead and hit that follow button. I will have that subscribe button soon, hopefully. Sounds like tubular bells. Something like that. What's that one? Tubular Bells? You ever heard that one? Sounds like someone's got to go buy Pure Moods Volume 1. There's some good songs on Pure Moods Volume 1. Oh my god. What was it, that piano one? Is it... Something like that. I don't know. It's really hard to play on this keyboard. Also, my hands are getting kind of cold, so what I do is I just, put them over a little open fire. Just a small town girl. It does sound like that. You're right. We keep track of if we visited a place by if we've been there facing that same direction. Is this an n squared algorithm? I believe it is. I would defer to Dark Space on that. Exorcist is old school, released in 1973. Just like Bash, released in 1989. Let's see. Did you implement saving the cost in the cache? I believe I did. Yeah, so when we cache it in our visited thing, like if we had a free space, we cache it. And we cache it with the location and the direction as the key, and the cost is what we're saving there. Then when we visit a new place up here, we check, we grab the data out of the cache, otherwise we defaulted to this really high cost that we haven't hit yet, 999,999. I can throw another 9 in there for good measure. I can throw another 9 in there, who cares? If n is less than cost, so this new one... God. I have over 100 viewers right now. All right. Everyone who's watching me, close your eyes, okay? I don't want you to see what I'm about to do. All right. I don't want anyone to see that. I don't want anyone to see that. I may have got my alligators and crocodiles messed up. You did tell me too. That's the worst part. The worst part is that you told me that. Well, this didn't work. What's a little inequality between friends? No need to see. I feel the pain. Now listen. To be fair, something didn't work. If n is greater than cost, of course it's greater than cost because we defaulted it to 0. So if we've never been here before... Oh! If we've never been here before, then default it to the cost because that's what it would take to get here. I could technically make it 0. Maybe you actually did have it the right way around. All right, listen, don't say things like that. Don't say things like that. Let me think about this. Okay. We're going to check if we visited here before and it was cheaper. So we grab the data out of the cache. Otherwise, we default it to the current cost because that's what we will set it to. If we've been here and it's greater than the current cost, we've cached it here, then we continue. No. Okay, now I'm confusing myself. Greater than equal won't help. I'm already defaulting it to cost. Stop. If we visited this location before, we'll have the cost of what it took to visit that location. Otherwise, we'll default it to our current cost. If... Doesn't really matter. You're also echoing before the visited check. Listen, I don't want people commenting on what I'm echoing and what I'm not echoing. You're right, it is hard to tell. I can just put something like that. So we are getting some visited. I started seeing them. Comments are no longer in sync, just like the real code. How much of backseating is the okay amount? That's the okay amount of backseating. I'm just telling you for your specific suggestion that I'm ignoring it right now just because I'm in a different mind process. My brain's not good. My brain's not good right now. So what are we doing? We're going to check if we visited here before. If we have visited in this spot before and the cost was less than our current cost. Wait, this is right then, right? If we visited, let me stop doing this. If we visited here before and the cost that it took us to visit here is less than the cost it would currently take, then we visited here before. Wait, am I wrong? Yeah, because if we've... I'm so confused. I'm confusing myself now. Where are you saving back to the cache? So in my logic, we have this like infinite while loop that runs. We pop a move off the queue. We read some data out of it. The first thing we do is we do the cache check. And then we check if we're at the end. So this is our end check. And then if we were not any of those, we check, did we hit a wall? If we hit a wall, we can't continue. We throw it out. And then finally, we know that we're at a period. It has to be a period. We assert that it's a period. That's when we save it to the cache before we in-queue the 3 new moves to the queue, which are, you know, turn left, turn right, and go straight. So this is where we store it. We know that in order to get to this location in this direction, it costs this much. So if we're up here and we pull that data back out, let's say it costs 5,000 to get there, but this current thing we're checking out is 5,005, then we don't care. We know we've already visited there and we can just not bother checking it. Yeah, if it costs us less than what it would cost us now, we need to just throw it out. Does the direction matter? What do you mean? If I've been to a... Yeah, I think the direction does matter, because if I've been to a square and it costs 1,000 points to get to that square, it matters which direction I was, because to push off that square and go somewhere else, like... Does it? Let me think. I think it does. Yeah, it's the currently facing direction at that particular square, and it costs to rotate, so it does matter. Yeah. But isn't cost the amount to get to position, comma, direction? Can't you save it if it's the new min? Hold on, YouTube chat. The direction absolutely does matter for the visited. It does matter because, like, it costs money to rotate. So if I visited a square and then I turn, like, left, I'm still at the same square. I'm just facing a new direction with a new cost. So if I were to say, oh, I've already been at the square, this is not viable, like, no, then I rule out rotation completely. But isn't dollar cost the amount to get to position and direction? Can't you save it if it's the new minimum? Yes. The cost is what it took to get to that position at that direction. That is correct. So when we pull it out of the cache, we say, hey, what did it cost to get to this location in this direction? And if you don't have an answer, like if this is the first time we've been here, let's just say it's a really, really large number. I could put, like, you know, U64 max here or something. If that number is less than the cost that we're currently checking, meaning we have a cached route that is faster, then we should just give up. Because we've gotten to this location before and we've gotten here faster. So we should just continue. We should just try again. We shouldn't even do anything with it. Otherwise, we've gotten down here in a cheaper way, or the same cost. So we don't know which one's better yet, so we have to still try it. We may have hit the end. That's awesome. we may have hit a wall, in which case we're not going to cache it. And then if we make it down here, if it is a free space, then we do cache it. So this will become the new minimum. Yeah, if we get down here. Okay, I guess that's fine. Yeah, I think it is too, which scares me. Like, I don't know. I don't know if I'm dealing with a bug or my algorithm is just fundamentally flawed. You know what I mean? That's why I'm worried about this. Because also, this is going to take forever. Because last time, in mine, I immediately save it to the cache. Oh, okay. Probably is faster to do that. Because then I don't have to, like, check if it's a wall or anything. Like, the cache will already, like, know that it took there. So there's no reason to even check it. It might be faster to just do that. Because I don't know how many turns it's going to take, but look how long this takes. Now, as it gets higher... Oh, we're starting to see more visiteds. Every time the output space is printing the word visited. Ivan, I need to better understand the foo default syntax. It sounds like you actually understand it pretty well. I mean, you nailed it, and that's exactly what it is. Yeah, because as this cache grows, it should get faster and faster. Because it's not, I mean, it's going fast. Not the fastest thing in the world. I don't even know what part 2 is yet. I can't even think about that. Yeah, we're only at 21 turns. Now, we know that it's 105 or less turns because Advent of Code told us that ours was a little bit too high. So that is good. And what is the map? Is it 141? We looked at the thing. So like 141 times 141 times 4 is how big the cache can be. Width, height, time, number of directions. I don't know what that number gets us. Just, you know, those are some fun numbers we could think about together. Starting to lose my mind. Listen, I still have 70 viewers on Twitch. I'm glad you guys are enjoying this. I'm slowly like descending into chaos, so I guess this is what happened with Piggy Bank, right? You're defaulting newly visited spaces to a really high cost and checking to see if the current path was cheaper than an arbitrarily high cost and saying visited. Did I read that correctly? Yes, you did. That's exactly what I'm doing. So I'm basically, here's what I'm doing. I'm trying to pull the data out of the cache. And normally I had before I had the logic that said, if the data was in the cache and the number was, you know, bigger than some cost, or sorry, less than some cost, then we break out. I turn that all into one line, just for the sake of what I thought would be more performant in Bash. So it's a little bit harder to read. But now I'm saying pull the data out of the cache or default to a really high number. Like this was just, no matter what, this is going to lose that if statement. Our current path will be more performant than whatever that path was. Looks like it's looping. I don't think so. It doesn't. Everyone keeps saying that. We're at 23 turns now. I bet it will get to 24 turns. But we'll see. I could be wrong. Of course I could be wrong. I just wanted some chatter in the background while coding, but now I've been nerd sniped by the Bash stuff. Yo, that's awesome. In the meantime, you can pull a real answer and run it. Oh, I could do that technically. Yeah. Yeah, are we at 24 turns? Did I say we were at 23 before? Yeah, I don't think we're looping. There's just a lot to check. I'm gonna quit this real quick. Wow, 5 minutes. I'm gonna look and see if there's any way we can do this faster. I'm just trying to think of ways to make this board performant. We know that the maze is solvable. We should never hit this. Okay. And we do this check, like, immediately. Yeah. Maybe we set this here. That way we don't have to check the wall and extract it from the grid. We kind of save some logic there. We don't need this assert. We never seem to hit it. No idea if that's faster or not. Basically, the caching logic should get hit faster, and we're doing less if statements. And we are crushing the CPU. I still don't think this is going to finish in any reasonable amount of time. It does seem faster. Check for walls before the end, since it's more likely. Yeah, I could do that too. Like, I think it's gonna take time. Yep. And then we cache it. We cache how long it takes to get to a wall. See, now the echoes are really fast, where I'm wondering if the echoes are slowing me down. Let's check this out. Check this out. Well, it would help if I used the right variable name. We're going to keep track of every time we make a turn. So we're not printing nearly as much, but it's still doing just as much work under the hood. And minus equal cost will also make it faster. I don't remember what my logic is. You might be right. I just have to think about that. If n is minus to equal cost. Yeah, you're right. You are right. That's significantly faster. That is significantly faster. Yo, shout out for that hint. Oh my god. Oh my god. Dark space, I might have a hint to get you more cache hits. Was it this? Because that made a big difference. I mean, now we're slowing down. Of course, we're going to slow down as we get more. But like... Now remember, we know that it is 105 or less turns. 105 or less turns. We know that. Because when I put in 105 as the answer, it yelled at me. So it said it was too high. No, it's not that. Interesting. Dark space, I am interested. I am ready for that hint if you would like to give it to me. I feel like... let me talk to the chat real quick. I feel like we've given it a good effort. We've put in a really tried and true effort here. We really tried. We're on the cusp of an answer. I think it's time for the dark space hint. What do you say, dark space? What do you think I need to do for my caching logic here? Use a stack instead of a queue. Kind of what I'm doing. Okay, I named it queue. Are you talking about where I enqueue my moves. I named it queue. I always take from the front of it. And what I do is when I enqueue moves, I put the trying to move forward at the beginning of the queue, because I always take from the front of it. So I always try to move forward, and then I take the one where I try to move left or right, and I put that at the end of the queue. So I don't know what this data structure is called. It's like a priority thing where like the beginning has all my forward movements, the end has all my turns, so I'm less likely to grab a turn. And I always pull from the beginning of it. So I may not be fully interpreting correctly what you're saying. I could be totally wrong here. I think it's a wacky queue. It is. You're right. Okay. We have 3 answers now. I didn't do any sorting here. We have 3 answers. This is the answer we got first. This is another one that would solve it. And this is another one would solve it. So at that turn, I think this is the answer because I'm using my brain to sort these 3 answers. So I think this might be the answer. But before we check it, you want to pop push from the front or back. Also, just embrace the turns. It will let a path fail faster. Okay. Embrace the turns. It will let a path fail faster. Okay. Let me think about this. You want to pop push from the front or back? Okay. I think I understand what you're saying. Let me try this. Let's see if this actually works. Let's go. You were all here first. That's the right answer. You are 1 gold star closer to finding the chief historian. Yes! Let's go. 4 hours, 30 minutes streaming, 4 hours working on the puzzle, and we nailed it. Let's go. First try. That's right. First try. We nailed it. What's up, Seeknate? You were here. Shout out Darkspace. You were here. Shout out, I'm sorry in YouTube chat, I forgot your name, but thank you for showing the less than equal sign because that was it. I don't actually know how to pronounce your name. I'm so sorry. Fretje. Thank you so much. Huge shout out. Yo, shout out. And I'm probably missing people. My apologies. Shout out everyone who helped. Oh my God. This was awesome. All right. So let's think about this. Before I jump into part 2, I want to implement Darkspace's thing, the stack, because I think that's going to help me here. So what we already have it open, right? Okay, so what Darkspace is saying is use a stack instead. You want to push pop from the stack. Also, just embrace the turns, it'll fail faster. So read part 2 first. Okay. Yo, Darkspace tells me to do something, I'm doing it. Now that you know what the best paths look like, you can figure out the best spot to sit. Oh, what is this? Every non-wall tile, okay, so the free spaces, is equipped with places to sit along the edges of the tile. While determining which of these tiles would be the best spot to sit depends on a whole bunch of factors: how comfortable seats are, how far away the bathrooms are, whether there's a pillar blocking your view. The most important factor is whether the tile is on one of the best paths through the maze. If you sit somewhere else, you'd miss all the action. Okay, so you'll need to determine which tiles are part of any best path through the maze, including S and E tiles. In the first example, there are 45 tiles marked O that are part of the least one of the various best paths. In the second example, there are 64 tiles that are part of the least one of the best path. Okay. Wait a minute. Am I crazy? It seems like this is going to be easy. I shouldn't say it. I gotta stop saying that. There are 64 tiles that are part of the best, at least one of the best paths. Yeah, wait, what? Hold on. CP part 1 new. I shouldn't. Part 2. Move part 1 new to part 1. There's no reason to carry around that old script. Let's look at part 2. So part 2. Oh, thank you. Right. Yeah, my bad. I was covering it. All I did was if you can look through the backlog and see what I ran here. Now that I understand the problem I'm going to have to solve, let's look at part 1. Let's look at my queue, which I call a queue. And we're going to leave it called a queue, and it's probably going to stop being a queue, but that's what we're going to call it. Let's not push to the front. Let's just always append. I think I'd have to check bash. I think that's the fastest operation, just the plus equal. We'll always move it to the end. And then when it comes time to grab something, we can grab it from the end. So we'll always push to the end and we'll always grab from the end. And the way we'll do that is we grab it there and then we will unset. So if this is correct, we will grab the -1 spot from the queue and then we will unset the -1 spot. So this will always, this basically, we're pulling off the end. We're always pushing onto the end and we're pulling from the end. Part 1, reading from example. Punches were shrugged off. All right, man. I'll come at you with more punches. That's wrong. That's wrong. Cool. So now we have wrong solutions because of how I did it. Yeah, that works. This stuff works. It's gotta be my turn logic that's bad. If turn's greater than last turn. Yeah, that we stop when we get to a turn. I don't understand how we determine a winner. I'm still on part 1, by the way. I'm trying to implement that, like, thing that Dark Space was talking about. I don't quite understand. I understand the logic. I don't understand how I make mine work like that. Oh, do we just go until we can't pop off anymore? Is that it? Seems slower, right? I can't tell if it's... That seems way slower. Alright, well, we have the working part 2. What was part 2? The reason the stack is probably faster is because it is implementing a depth first search instead of a breadth first search. You'll reach the end faster and you'll know your current best solution, and maybe you can use that to prune. Oh, that makes perfect sense. I totally went with breadth first. But I understand what you're saying. Yeah, find a solution right away, and then when it's cached, we can just start throwing out other solutions pretty quickly. I understand what you're saying. I'd have to do some work to, I think, make my implementation work like that. I do understand what you're saying. I'd have to make some changes to mine to make it work like that, in which I might have to, just because of just the speed alone. It's such a good increase. I understand what you're saying. Yeah, and then when we run out of moves, then we're done. I don't know how to get... I'm just thinking out loud now. Yeah, because like that cost is ridiculously high, but by doing that, we've cached a lot of values really quickly. Yeah, we've pretty much hit like the max turns, and now we're working our way back. This might actually, I'm going to be honest, this might be a case where the echo is actually slowing us down. But I can see the vision here. Yeah, the faster I can get this solution, the better it'll be for part 2. It's cool to see it count down. We may have hit a solution really quickly. I understand now. We may have hit a solution really quickly. Yeah, like if I had like best solution equals, set it really high. Once we get a winner here, if cost is less than best solution, then best solution equals cost. I don't know how long it takes to get a solution, but once we get a solution, it should be like stupidly fast. I can also cheat. I can totally cheat because I already know. This seems unfair. I already know the best score for this one. So like I can literally just use that as a starting point. Like, isn't that kind of unfair? Also, there's going to be multiple best paths, but I think this one only had one. Echo out the best solution. I don't think I ever hit the best solution. I don't think I even salted in that time. I'm going to cheat. Not cheat, I mean technically this is allowed. I'm going to use the what I know is the best solution to seed it. Instead of 99999, I know it's 105,496. But if it's still 99, you'll know. And I mean, put it in that one main echo. Oh, I see what you're saying. Did I? Where did I? Oh, don't do this. Yeah, I'm kind of not really cheating. I'm just taking a little bit of a little shortcut. Exactly. I wonder if I have to make it one higher, put like less than or equal or something. I think I'm still good, but I'm just going to make it one higher. I think I'm still good. So I have no frame of reference for how long this will take, but we'll let it run. It only took 2 minutes and 55 seconds. It's not the worst thing. I'm still letting this run over here, but I'm looking at part 2 now. Because for part 2, we need to look and figure out We only... Okay, here's the nice thing. Is we know there's only one best path through our maze. And we just need to keep track of how many tiles were in it. Like, this seems actually really easy. Because my thing kept track of cost, which I still will do. And we even keep track of the number of turns. Do we even use that anywhere? I think we use that to stop at a certain point, but we didn't even bother with it, right? Yeah, we didn't even keep track of it. I guess we use it to determine the winner. Yeah, we did. Okay, so we keep track of the turn. How about, seats? We're just gonna add more data to it. Yeah, we're just gonna add a new piece of data to this, which is the number of seats that we've encountered. If we move them up, then the number of current seats increments. But if we do a turn, then the number of current seats is the same. Yeah, that should be it. Where we in queue, we just need to include that. I think that's literally it. I don't think there's much else that needs to be done. Let's try some examples. This one's not working. Whatever one I did to fix it did not fix anything. Yeah, oh well. I completely understand what you're saying, and it should make it faster. I'm willing to bet there's just some weirdness with bash and pulling things out and string manipulation. And honestly, pushing to the end of an array might not be the fastest way to do it. Like, once you start having big arrays in bash, things get bad. So I'm willing to chalk it up to some weirdness with the language. 736 has 36 seats. So the first example, there are 45 tiles. And I think that's because there were multiple best paths. No, I don't know. The second example, there are 64 tiles. So it should be 45 and 64. We have 36. And we have 48. Okay, so neither are wrong, but they're both less. Let's make sure that we are not doing things stupidly. How is this wrong? The fifth argument of NQ. Okay. 70, 36. Should have 36 seats. Or no, we got 36. It should be 45. Now, it says at least one. So I'm thinking it says at least one, that you have to put all the best paths together. And I'm pretty sure mine only had one. So I might just be able to cheat. You know what I mean? Like, I think I might just be able to cheat. Like, I think give me 3 or 4 minutes and we just cheat, right? So this algorithm won't work for everyone's input, and it'll just work for mine. Yeah. Campo says yes, so yeah, that's... yeah. I mean, hey man, it is what it is, you know? We're 5 hours into a stream, we know what's up. Also, thank you everyone for hanging out. I realize people are being real quiet, and that's cool. People put on programming streams to just hang out and chill in the background. So... yeah, that's perfectly fine. It doesn't need to be generic. Yeah, I agree, 100%. Yeah, I just need to get the answer. Technically speaking, you know, I could take my input and just start drawing lines to the puzzles. Like, I just need to get the right answer. So, oh man, Advent of Code is so fun. It's because I was gone, obviously. Oh my god, it's like an echo. It's like Warforged is still here. Ooh, this candle's so nice. Technically here again, finished making dinner, and you're still here. Listen, man. Things are not going great. Oh, dinner. That sounds good. I got 1 protein shake left tonight to fill my macros, and I'm looking forward to it so much. Oh my god. Listen, guys, don't let your health get away from you, guys. Cardio and watch your weight. It's important. Don't be like me. Or be like me now that I'm disciplined and driven. Don't be like me when I was lazy and just getting DoorDash every night. It's cold. It's cold outside. That's what it is. Pretty sure it's below freezing. Oh, also, I'm just exhausted. I was doing demo work with my mom, so she came over. We were working on my downstairs bathroom. I'm ripping down all the drywall, all the fake tiling. I had to reinforce a header and rip down a load-bearing stud. And man, after just bags and bags of drywall to the trash, dude, I'm spent, man. Absolutely spent. Winter Wonderland, yeah, Winter Wonderland. No snow and freezing temperatures and rain that hurts. Yeah, I agree. Part of the U.S. are you in, Dave? I'm in New York. But yeah, my previous DoorDash order, I don't remember if I said a pizza, any form of large pizza, Pizza Hut. Hey, look, we got some answers. Let's see what we got here. Look at this. Easy, easy, easy. So the lowest one is this one. 496. Is this just... am I stupid? It's just this number. But of course it's just this number because there was only one solution. If there were multiple solutions like this, the number would be different. It would be, you know, the difference between it. So it could have been between 496 and 508 or some mixture of them. Yeah. But for me, because there's only one best solution, it's 496 because it's just this part of the number. Oh my god. Of course. Of course. Oh, that's not the right answer. Your answer is too low. Curiously, it's the right answer for someone else. God, what's going on here? So this one's too low. It's too low. Too new. It would have helped, I think, if I printed them out. Visual inspection of this would be useful. Is it 500? I can't just try the other two numbers. They put you on some sort of cooldown. So like if I did this and hit enter, 15 seconds. It's not that big of a cooldown. There should be multiple paths with the best cost. I understand what you're saying, but there's not for my puzzle, or at least not that I was able to determine. For my puzzle, there was one path that was the best. The rest of them were slightly too high. That's why I love doing AOC instead of game render loops, so I can visually inspect bugs. Yeah, that's super useful. We've been here. We've been here in a cheaper way. Yeah, I think what we're doing is we're filtering this out. We're basically saying, oh, we've already been to this thing with the same cost. So we throw out the beginning that got us there. I think it needs to just be less than here. Because now we're saying, like, you know, if we get to the same location and it costs us less. Yeah, if the cache version is less, then we throw it out. We were throwing out if the cache version was equal, but there could be multiple ways to get to the same path. But the problem with this is that made it take so much longer to run, if you guys remember. The cooldown gets longer the more wrong answers you give it. I've seen it go up to like 10 minutes. Oh, okay, so it's like an exponential back off. That's pretty funny. Makes perfect sense that it would be, but yeah. Might be overlap with coordinates, and also the results aren't the best paths. Well, I know I got the best path because I got the first one right. This won't even give me the answer. This will just give me a bunch of numbers. I think I'd have to store all the coordinates they visited and then dedupe them. Oh, man, this sucks. This is one of those things where I think... This is one of those ones where I think if... Brain's broken. All right, hold on. Let me fix my brain. Brain's better. I think if I rewrote this, in Rust, I could get it to work because I can make it go faster. I can store more data types. I think just the speed benefit alone of that would make it so this solution would just work. I want the answer in Bash, but do it live. Listen, man, I've done it before. I've done it multiple times, multiple nights. I've like rewritten it in Rust, and you know, it works. Or I go back to the Bash solution and fix it because I thought of something different. Can always run the Bash solution in the background while doing the Rust port. That is very true. Okay, so there were 3 solutions with 36 seats. So technically speaking, I could rewrite this script to make it work in Bash alone. And that way when I ran it here, it would work. Oh my god. Let's see. I'm getting a little bit tired, but we're having a good time. We're having a real good time. Do people want to see me rewrite this in Bash while this is still going on? So I'll let the Bash solution run. This won't give me an answer, actually. But I could rewrite it in Rust just to make sure that my approach makes sense. Would people be interested in that? Yo, what's up, Land of the Elite? How'd you know I suck at programming? Dude, I had a feeling, man. I had a feeling. I was thinking about you earlier. I was like, dude, Land of the Elite? Person doesn't know how to program, man. What a loser. Let's do some Rust. Yeah, I figured people would want that. Rust, Rust, Rust. Yeah, everyone's saying Rust. Yeah, I just don't know. I just don't know when this will finish, you know? All right, people interested in Rust? Let's do it. Let's do it. Just call it Rust Imple. It doesn't create a Git directory. Okay. I have some other Rust ones too, so let me go ahead and cp day 13, Rust part 1. We'll keep copy over the git ignore and the rust format.toml. I like those two files. We'll copy those to day 16 Rust Imple. Nice. And then I will look in those because I think I've done logic that can just be copied over. I have a darkspace.txt file in there. That's so funny. I'm just going to grab some existing logic to read in a file because I don't feel like writing that again. This is not a great one to read. Day 9. All right, well, apparently I didn't do any sort of 2D vector stuff, so... all right, we're doing this in Rust. That's what's happening here. Pizza with 4 different types of topping? No. Pizza with just cheese. Quesadillas with just cheese. Noodles with butter, sometimes sauce. I eat like a literal 4-year-old. The doctor thinks it's autism, but I've never actually been tested. But like, yeah, man, that sounds right. Pizza with 4 different types of topping. I already read that. I'm the same way. Are you? Yeah. I don't know if you're gonna be as limited as I am, just because most people aren't. But I'd be curious. We work in tech, so we're probably on the spectrum somewhere. Dude, honestly, man, it's true. Like, whatever. It is what it is. Add ramen to the list? Yeah. No ramen for me. If I do, it's like super, super fake stuff. I don't eat meat, like, at all, so. What do we have here? This would just be a string of the input, right? Yeah, that's just the input as a string. Okay, so we can do for line in input dot trim dot lines for C in line dot trim. There shouldn't be to trim here. Line dot chars. Do I need to do an iter there? Just see what this is. Okay, that seems right. I feel bad. Normally I'm like talking about what I'm coding here, but I'm so in focus mode, you know what I mean? Can I just do char? I think I can. For y in There we go. I think I can do this. So I should be able to do this. Does that not work? I can't just... I actually have to say they're vex of vex? I thought that would just, like, work. Whatever. I'm too far into it now to worry about that stuff. I need a Rust expert to explain why that didn't work. Oh. I get, because the first one is the reference and the second one isn't. Okay. I actually do understand that. That makes sense to me. Okay. What are we doing? I already forgot what I was doing. Okay, we're pushing on the C. Okay. Let's make some enums for this. We have a free space and we have an obstacle. That's it. We'll do a match statement here. What's your approach to the problem in Rust? We're going to find out. You and I are going to find out together what my approach is. What do we call it? Block. Okay. If it's a period, then it is a block free. If it is a pound sign, then it is a block obstacle. If it is S, then let's make a new type up here. We're going all out, okay? Struct point U64 pub X is a U64, pub Y is a U64. So now we can create points in space. Awesome. We need to enumerate these. Can you generalize your thinking with Rust as opposed to Bash? I don't know what that means. I'm not sure what you're asking there. Do you want me to start like talking through the problem like I'm running Rust? The only reason I'm not is because I'm streaming for 5 hours. I'm just exhausted. Honestly, that's the truth. No worries. Okay, yeah, cool. Yeah, I normally would. I'm just a little bit exhausted. That's really what's coming down to it. So what I'm doing is I'm looping over the puzzle input here, and I'm matching based on what we get. A period is a free space, pound sign is an obstacle, S is still a free space, but we also know the starting point, so I'm going to save it as some point. So I need to save the X and the Y here. And the way I can do that, we're going to have to actually enumerate these. So this would be the Y. Trim.lines.enumerate. Block.chars.enumerate. This means enumerate, give numbers with. I actually don't know what the definition of enumerate is, but something like that. Make numberable. So now we have X and Y there. So we have the starting point, and we also know that we should return block free. No comma. And then for this, we have the end. and it's also a free block. Down here, if we get anything else, we just panic because we don't know what to do with that input. That does not compile. Expected U64 found U size. Did I specify U64 somewhere? Hey, I did. Oh, it's a lowercase derive. Eh. Why am I... Oh, I hate that I'm doing the bash one first. 58. Yeah, and then print grid doesn't know how to print this. Actually, wait. Can we just call like 2 char on it? And then do impl block pub fun 2 char. Takes a reference to self and returns a char. I think we can. So if it's the free, this is just going backwards. So if it's the free, we return a period. If it's the obstacle, we return a pound sign. Did I not call 2 char? I did. Why didn't that work? I see. I don't see. Oh, okay. I do see what's going on. It's because of the function signature. We're taking a vec of chars. That's not correct. We're taking a vec of block. A 2-dimensional array of blocks. That should work. Cool. It works. Cool. Hey, that looks pretty good. No, you look pretty good. So dumb. Cool. So what's the algorithm we're trying to do? We're going to make our other struct. Our struct will be called a task. A task will have a point. This is the location. It will have a direction. We need to make direction, don't we? A direction will have 4 possibilities. It'll be east, south, west, north. And we'll give it some functions. Clockwise and counterclockwise are the functions we will give it. They'll take a reference and they'll return a new version of themselves. So now we can match on self. And if it's north, we'll return... what is clockwise from north? East. There we go. If it's east, we'll return south. If it's south, we'll return west. And if it's west, we'll return north. So now we have clockwise. So let's go ahead and give it counterclockwise. If we have north, it'll give us west. If we have west, it'll give us south. If we have south, it'll give us east. And if we have east, it'll give us north. Cool. So now we have really good functions on that. So our task will have a current location, a direction, the cost, which is a U size, the seats. Let's not even worry about that. Yeah, let's just do that. Let's just do that. Cool. So now we have a task thing, so we can enqueue tasks. So what's the first thing we do? We enqueue some moves. So we need a queue of moves. It doesn't return anything. We'll take the queue. We could make this a struct. That's what we want. Try move forward, try CC. Okay. Okay. Now, in order to move forward, does Rust have a stack data structure built in? Probably. I mean, I can just kind of treat a vector as one. I can just pop off the beginning if I wanted to, or push onto the beginning, insert at the beginning. I don't know if there's anything else like specifically built for that. There probably is. I just don't know it. I'm not going to bother with it. If we're going to enqueue a move, what do we need? We need the location, the direction, the cost, and the turns and stuff. Whatever. We need the location, which is a point. Whatever. The location, the direction, and the cost. Is vec backed by an array? Vec is basically an array. Vec is the standard lib data structure for, actually I don't even know if it's standard lib, but it's the data structure for having arbitrarily sized arrays, kind of. Yeah. Mega points for perseverance. Yeah, thank you. I might just actually be stupid. That actually might be the real thing that's happening here, but I really want this answer now. There's probably a DQ, double-ended queue, so you can use it how you want. Yeah, there probably is. I think there most likely is, which probably is what I want, right? Because I was going to put things on the front and put things on the back. Not that it really matters. Stack is probably the way to do it. But yeah, I'll look into that if I encounter that. So when I enqueue moves, we need to make a new task. Not yet. Let me think. Match, direction, this look copacetic? Yeah, it's just taking more things. So for the first in queue, where are we in queue moves? We clone the starting position. We set the direction equal to south, or nope, east. Do I have that right? Is it location direction? Location direction cost. Cost is 0. Awesome. Popping the first element of a VEC might be an O of N operation. Popping the last element should be fine. Not sure if that matters. Specialized queue stack structure should do it in O of 1. Okay, cool. Yeah, I'll look into that. Probably need some sort of DQ, which is what, yeah, Dark Space said in the Twitch chat. So yeah, I think you're right. Okay, so these are not clonable. They should be, because all their underlying things are. So let's just go ahead and make our lives easier, huh? What was the other thing yelling at me about? Types differ in mutability. Yeah. It's pronounced deck. Hell yeah. What goes in a task? A task is a location direction cost. Cool. Task is location, which is next loc. Direction, which is the same. And the cost is the cost plus 1. I was working on the math for the 2019 problem. Oh, God, yeah, good luck. I'm afraid to look at those problems. No Rust experience, but I Google something now. Standard collections VEC DQ might be a thing you're looking for. Sorry if that's too much of a backseating. No, you're fine. That is not backseating at all. Looking up, like, the specific names of the implementations, like, I'm totally fine with that. Yeah, I might look into that then. I might change it from a VEC to a VEC DQ. Sorry, a VEC deck, according to Dark Space. Q.push task. Does this work? Where? Okay, nice. So now we're going to try and move clockwise. So in order to move clockwise, we just need to say the location is the location.clone. The direction is the direction.clockwise. Hey, look how easy that is. And the cost is cost plus 1,000. This is it. Yeah, this is absolutely it. Oh my god. That's it. Now we have new moves in queued. Now we can go into our while loop of try moves, which is just an infinite while loop of popping it off. Let's go look into DQ. This is what we have here. Standard collections VEC DQ. What do we have? We have append. Moves all elements without leaving. Okay. Oh, you just actually append. So there's going to be a push, pop back, pop front, push back, push front. Hey, that's beautiful. This is exactly what we want. So let's go up here. Use standard collections VEC DQ. Let's change the underlying backing store of our tasks. I think we have a VEC. Yeah, VEC DQ of tasks. Now we can do push front, push back, and push back. And then what we do down here in our loop, we can do let task equals q dot pop front. There we go. And if I had to guess, pop front returns an option. That's exactly what it does. Cool. So now we can do this. Instead of doing that, we can say match on that. And if it's some, then we'll just return the item. If it's none, then we know that it's empty. And what do we do when it's empty? Let's go look at our old code. We didn't actually do anything here. So let's just put something in there. Let's just, I don't know, panic. For now. We'll figure it out later. Okay, so now we have a task we need to work on. So in order to work on this task, what do? We check if it's the last turn. Let's worry about that later. We check if we visited before. DQ is more descriptive of what's going on than def. Def a better way to say it, in my humble opinion. I'm going to go on a limb and say Dark Space was not being serious. I'm just going to go on a limb and say that. Because I agree. What do we use for our cache? We used a hash map, right? All right, so so this will get us that cost. Remember I was showing that in my code before? Yeah, this gets us that cost, and then we did or 999999999. We can actually do that here. We can say get it from the cache, unwrap, or we can do, I think, like use. Is there usize max or something? What is the max? U64 max? There's a size usize max. That could be. I'm making up syntax here. Oh, I have to borrow it. Oh my god, is it actually working? No vec DQ in collections. Okay. Yeah, we should probably make one here. It's the visited one that's causing problems. That's fine. No, it's not fine. It's not fine. If n is less than cost, if task.cost is less than cache, then this one's better. So if cache is less than task.cost, then this one's better. Now we should cache it by doing visited.insert task.location.clone, and we will put the cost in there. And this should work. I could put just like a star there and get it out of this. Oh my god. Okay. So we're doing something. Now we figure out if there is a wall there. So the way we do that is we grab the thing out of the grid. Block equals grid. Task dot location dot y. Task dot location dot x. Nice. And we can't take, it's going to yell at us if we try to take it out. So if, let's match the block. If it's a block obstacle, then continue. Else we do nothing. It's going to yell at me and tell me to replace that with matches. That's fine. Oh, that bash one's still going. We're only at 38 out of 39 turns. That's so funny. Yeah, we're going to refactor this whole thing into Rust before that even comes close. Check if we won. If task.location equals end, then we win. What do we do now? Oh, we stored the winner. That's what we did. We'll get to that in a second. And then if we get down here, we just enqueue more moves. That's easy. That's super easy. I feel like we could just pass a task in. Okay. Didn't do anything. It just didn't do anything. It's not gonna work. I can't debug print it. Or I can't two-string it, so I have to debug print it. Okay. Did it not think that we got to the end? The end is 13-1. We didn't even try and get there. So what happened here? What got you into Rust, and is your Rust Bash your main languages you work with? Yes. Just got into Rust because it seemed like a cool language everyone was working on a couple years ago, and I really liked it. I got into it, I'm like, this is awesome. Before that, I would say it's C, probably. But I'm just like really comfortable with Rust now. I really, really like it. I like all the data structures I have in the standard library. What am I doing wrong here? Pop it off. If what we have cached is less than cost, then we don't bother. If what we have cached is less than cost, then we don't bother. Yeah. Best part of Rust is cargo. That is so true. It really is. Cargo really is, like, incredible. It's just so easy to work with. I think it's your hash map key. Do ya? Do ya now, wise guy? Let's take a look. The location. You're right. You're right. You're right, you're right, you're right, you're right. It needs to be a tuple of the task dot location and the task dot direction. You're absolutely right. Good call. Oh, I like pair programming, except pair is everyone on the internet just watching me program. It's great. Okay, so that printed out a lot more. Actually, wait, no, this is good. Because it probably got a winner. So if I run this in grep for winner. Yeah. Hey, look at that. 70-36. So once it got a winner at that... Wow. Guys, how much faster is Rust? It's actually insane. Yeah, it's my pair programming. This is my YouTube chat programming. Rust is so fast compared to Bash is so slow. Why am I doing this to myself? Alright. So here's what we'll do. We'll do let mutt best score. This is our best score so far. Equals U size max. Should go in order. We have a winner. Okay, so if let me think about this. Task.cost is greater than best score, then we found all the best paths. I think this is right. If we found one that's higher, then we know that we found the best path. So process winners here and exit break. Okay, up here, panic. Maze is unsolvable. Cool. Now we can only break out of here one way. All best paths found. So we found all the best paths here. Best score equals task.cost. Cool. I wonder if this is even solvable on something like Commodore 64. I believe it would be if you find a better algorithm than what I'm doing. Okay, so we found 3 best paths for that. And we found 2 best paths for that. I'm afraid to run this against the real input. Because, like... Okay. It's so much faster. Guys, it's so much faster. Why don't I just start it in Rust? According to Advent of Code page, my answer was 105496. 105496. Do you see how much faster that was? I know that it's a self-imposed challenge. I know that it's a self-imposed challenge. Okay. Here's what we should do. Best path equal any successful path. No, best path is I'm going to keep going till I find lower scores is how I'm approaching it. So when we get to the end, I check if there were scores lower than it, and I just stop doing it. So apparently we can hit that panic when we run out of things to do, or we've gotten to a lower score. That's okay. That's okay. That's okay. Yes, we're good. We're good. So now what we'll do is we'll keep track of the winners. So every time we have a winner, then we break out else they're equal or they're less than. Else if task.cost is less than the best score, so this task is the new ultimate winner, we should empty the winners. Completely empty the list of winners because now we have a new list of winners. And now that we're down here, we'll winners.push task.clone. How do you empty a vec? Train? Rust vec remove all elements. Is there like a remove all, drain all? There's got to be something like that, right? Oh, interesting. You can truncate. I could just truncate it to 0. Oh, when truncating is to 0, you can truncate it to 0. It even says in the documents. I'll show you in the documentation. Yeah, truncating when length equals 0 is equivalent to calling the clear method. So, yeah, just call the clear method on it. Okay, if it's less than that, then we clear it. Then we save it. Okay. All best paths found. Cool. So now that we're down here, we can just do like for winner in winners, print line. We'll just print each winner out, which is a task object. Cool. So here's our winners. This was the cost, this was the cost, and this was the cost. Awesome. Assert that winners, that there is at least something in it. All best paths found for cost, winners 0.cost. Cool. So now, for every single task, this solves part 1. This actually does solve part 1 now. It's so fast. It's so insanely fast. Why don't I just use Rust? Instant. We get 105, whatever that is. 105,496. That is my answer. So now that we have that, what we need to do is for all the winners, we need to store where they went to. So every task should also have a visited thing, which keeps track of every block that it's visited. No. Yes, but no. Steps. These are all the blocks that it has visited. And it will be a vec of points. Okay? Bear with me now. Where do I make this? Okay, I literally just make it here. Okay. So, when we in-queue moves. I don't know if that works. We're going to see if this works. I'm kind of making up syntax now. Did I not call it blocks? What do I call it? Steps. It's called blocks. I should just pass the task object in, shouldn't I? That's what I'm going to do. Okay. Why would I need to clone this? I'm trying to give it away. Oh, I see what's going on. Reuse the same variable name. Yeah, we're going to take ownership of task, push 3 new tasks, and then just drop ownership of task. We don't actually need it for anything. Oh boy, it's a lot. Glad you all bared with me. All right, so for each winner, we're going to go through the blocks and insert them into the hash set. And then we're going to count the hash set, and that will tell us how many seats there were. You are flying through this, man. It's dope. Well, here's the thing. I've already put all the thought into doing it in Bash. And as part of that, I also put all my thought into how I would do it in a real language that had, you know, actual structured data and good algorithms. So, like, when it comes to just reimplementing, I'm just copying logic I already had and logic I wrote in my brain. So, like, yeah, I'm flying through this. Let's see. All best paths found for cost 7036 found 0 seats. Okay, that's not great. Why did we find 0 seats? Yeah, all of them have 0 blocks in them. That's not right. So where we're adding blocks, something is breaking. Oh, yeah, of course, because we're just cloning it here. Yeah, hold on. Let b equals task.blocks.clone b.push task.location.clone. We need to actually push location here because when you move forward, that's the only time that we do that. Now it'll work. Well, it'll work once I make this mutt. Found 44 seats. According to this answer over here, we should find 45. If I had to guess, we're not counting the beginning or we're not counting the end. So I'm willing to bet we're always going to be off by 1. That'd be my guess. Just initially. That's exactly what it is. That's exactly what it is. Because we're not pushing the block that we started at, which is start.clone. I had this logic before and I took it out. So this should return 45 at the bottom. Still returns 44. Let me see. Okay, so we found 44 when we're supposed to find 45. Now what we could do, I think we could graph them. We could print them out. Let me see what's going on here. Yeah, we start with ourself as a block. And then when we get to enqueue the possible locations, we clone the block and then we put ourself there. Oh, we're putting ourself there. We need the next location. That's what we're doing. That's it. I was using the previous. We need the current. 45. That's it. So the next one should be 64. 64. You ready? Yo, what's up? First time chatting on Twitch chat. How you doing? You ready for this, everyone? We're going to do the real input in Rust. We've already compiled it with release flag. We're going to see how long this takes. Let's do this for real. Ready? Cargo build -- release. Make sure it's built. Time target release Rust impl real input. Okay, it took 2 seconds. Okay, this is the correct cost. This is how many winners there were, and there are 524 valid seats. Is Bash still running? Yeah, before we do this answer, let's check if Bash is still running. Oh yeah, we're at 46 to 47. And we need to go to 105. We're not making it there. We're not making it there. Now do it in Bash. Get out of here. Sorry, Bash. You've ran for over an hour. We're done. Now, watch this answer not work. 524. Let's go. Let's go. Oh, that's what I like to see. That's the right answer. You are one gold star closer to finding it. Why didn't we just start with Rust? No, I like doing it in Bash as a challenge. I didn't get it in Bash. My algorithm is correct. I believe it's correct, but passing around that data in Bash is just awful. We could cache things to the file system. We could absolutely cache moves that we've made and stuff like that, but it's not happening. I have been streaming for 6 hours. It might be the inefficient queue implementation. It doesn't help. It really doesn't help that I'm doing that. Yeah, there could be something going on there. But you know what? I am very happy with a solution that takes 2.5 seconds to run. Again, this is something that could be parallelized. There are ways to do that, but I don't even care at this point. It worked, and we got the answer. Thank you, Rust.